To solve for the integrating factor, it's very important that we structure our linear equation in its standard form. The standard form of a linear equation is in this form. The first order derivative of y with respect to x plus a certain function p of x y is equal to f of x. Now f of x here clearly should only contain a variable of x for a linear equation. And this function here, p of x paired with our variable y, is also very important because that is what we'll be using in solving for the integrating factor. By the way, in solving for this given linear equation, using the idea of linear equations, we need to identify our integrating factor properly. And the integrating factor, mu of x, can be solved as e to the power of the integral of our p of x dx. So we need to identify p of x from our standard form and our f of x, which may not be used right now, but it will be used later on as a second part of solving right after our integrating factor. There would be a separate video for that. Looking at our given function, it's not yet in standard form because you can see a certain variable x here. So that would mean let's try to divide or multiply 1 over x on all terms so that on our first given term on our left hand side it will only be dy over dx following the standard form, minus you will have 4 over x y. Okay, and then on the other side, by multiplying 1 over x, since you have x over 6, you will have x to the power of 5, that's minus 1, e to the power of x. This is now in its standard form, and with this item here is already your f of x. Again, it may not be used in this video, but it will be used in part 2, the continuation of this. You have x to the power of 5 times e to the power of x. That's your f of x. But for our p of x, we'll be taking this, the function with x. This is what is paired with the variable y. And that is actually minus 4 over x. Not just 4 over x, but more importantly, it's minus 4 over x. The operation before it becomes its sign. Now with this in mind, we can now solve for the integrating factor. You have here the integral of p of x, which is minus 4 over x, and then you have dx. Simply take the integral of our exponent. You can do it like this, e. You can take out minus 4 if you would like to. You have the integral of our 1 over x dx. Okay? Now, let's continue this one here because the integral of 1 over x dx is just equal to the natural logarithm of the absolute value of x plus c. Or you can just simply write negative 4 natural logarithm of x. So what is now the simplified form of this? Let us use the idea of the power rule or power law for our logarithms, because ln, or is also known as the natural logarithms, also follows that idea. So you will have this form here, e to the power of natural logarithm x to the power of negative 4. The reason why we're doing this, because this can be simplified further, leaving this alone. That would mean our integrating factor mu of x is simply x to the power of negative 4, or 1 over x to the power of 1 over x to the power of 4. Either of these two is correct, as long as, don't forget that this is our integrating factor of our given equation. This will be used on our part 2 as we are going to continue solving for this given equation, which will also use the idea or the given for our f of x. Take note that we started with making sure that our given is expressed in its standard form before identifying p of x and f of x. Thank you very much for watching.